we're going to talk about the horizontal asymptotes. Now, this is not quite as simple as finding the vertical asymptotes. In order to find the vertical asymptotes, all you would have to do is set the denominator equal to 0. So, for example, if I set this equal to 0, I would get a -2, which is exactly where my vertical asymptote is located. Now, we do have all those rules, okay, to find the horizontal asymptote, but I'm going to simplify them for you. We've talked about them briefly in the past, but if the degree of the function, alright, if the degree of the function is bigger on the top than on the bottom. Remember, when we talk about degree of the function, and I can give you an example of that here in a minute, we're talking about, for example, if I have something like this, for example. If you have some function as simple as that, and I'll even make it like plus x squared or whatever, okay? The degree of the function on the top is 2, because that's the biggest power, and the degree on the bottom, look at the variables, look for the biggest power, that's 3. So the degree of the top is 2, the degree of the bottom is 3. If you happen to have that, then we're going to call the horizontal asymptote. To find it, we're going to call it BOBO, alright? BOBO means that this last letter gives you what it is. The horizontal asymptote, therefore, is going to be y is equal to 0. That's pretty much it for that one. Okay? Now, if you have something where the degree of the top and the bottom is the same, alright, so let me give you an example. If you have something where the degree of the top, say the degree of the top was 4, and let's have a 2 here, and maybe, I don't know, even a 3x over, let's make this x, let's make this 5, I don't know, something like that. But again, look for the, I don't know, we'll make this a square, just for fun. But remember, you have to look for the biggest power, so the degree of the top is 4, the degree of the bottom is 4. Alright, so if the degrees are the same, you're going to take the coefficients, so the horizontal asymptote, alright, to remember that one, we call this bottom equals top, Betsy, and the C stands for the coefficients. So my horizontal asymptote is going to be the ratio of those two coefficients. Alright, so you have 2 over 5. By the way, if you happen not to have a number in front of this, that would just be a 1. So if you just had an x to the 4th, that would be a 1 up here. Okay, that would be the coefficient. Alright, finally, if you have something where you have the degree of the top, is greater, then you have no horizontal asymptote, right? Just to give an example of that. I don't know. Let's just make it that. Okay, if you have something like this, the degree of the top is 4, the degree of the bottom is 1. If that happens, then your horizontal asymptote is what we call BO2. Bottom, bigger on top. Alright, so bigger on top is undefined. And if the horizontal asymptote is undefined, then we're going to say no horizontal asymptote. Or you can say or undefined, either one. It turns out that's the slanted asymptote, but we're going to leave that up to your pre-calc teacher to teach you that. Alright, so again, BOBO, y is equal to 0. Betsy, y is equal to 2 over 5. Remember, BOBO means bottom, bigger on bottom. Alright, bigger on bottom, y is equal to 0. Betsy, bottom equals top is the coefficients, and BO2, bigger on top is undefined. Don't forget those, alright, because it's easier than try to go through this mathematical jargon. Alright, so let's go ahead and actually use those rules to figure out the horizontal asymptote. And in this, we're not going to talk about we're only going to talk about the horizontal asymptote, right? So look at the degree. Degree on top is 3, degree on bottom is 2. So look at or if you wrote them down, look at this, look to see if it's bigger on top. Alright, then this is going to be undefined, or no horizontal asymptotes, alright? So we can either write define, undefined, or none. Okay. Now look at the next one, alright? If you don't have a power, that means that the power is 1, so this is power 1, that's power 1. So you have the same power, right? So bottom equals top, so the horizontal asymptote is going to be the ratio. Remember, this is Betsy, bottom equals top. And maybe I should even write it for you. Okay, so that's going to be 2 over 1. Remember, this is technically a 1 right there. So that my horizontal asymptote is, look at y is equal to 2. 2 is a horizontal line. Okay. On this number 3, the degree on the bottom is bigger, so bigger on bottom, Bobo. Oh, friendly Bobo. That means that y is equal to 0. I don't really care what the numbers are, as long as the degree of the bottom is bigger than this degree, then you're always going to get the same answer, y is equal to 0. Right, finally, one that it's not really tricky, but if you just have a constant, meaning a number, then this would be, you would actually call this like degree 0, if you will, if you want to look at it like that. So this is degree 1, so it's bigger on bottom. One more time, this is going to be Bobo. So this is going to be y is equal to 0 again. Okay? Now, on the next few, we're going to just kind of review what we just learned and everything we learned about vertical asymptotes. Right? For the domain and vertical asymptotes, for both, remember, all you have to do is set the denominator equal to 0. And when you do, you get x is equal to negative 2. And that both gives you the domain, which means it's all real numbers, except for x cannot be equal to negative 2. But it also tells you that the reason that x cannot be equal to negative 2 is because there's a vertical asymptote at the same point, or at the same line, I should say. So again, if you know that, it gives you both domain and vertical asymptotes. If you don't remember that, go back to the lesson prior to this, which is 7-1, and refresh yourself on that. Right, horizontal asymptote, let's look at the degrees. Degree of the top is 1, degree of the bottom is 1. So is bottom equals top, so that's Betsy. Remember, that's the ratio of the coefficients. So my horizontal asymptote is going to be the ratio of the coefficients. Right, the coefficients of this would be 1 and 1. So this would be 1 over 1, which is 1. So therefore, my horizontal asymptote is 1. Alright, let's move on to number 6. Alright, same idea. Remember, to find both my domain and my vertical asymptote, I have to set the denominator equal to 0 and then solve. In this case, that's going to be x plus 3, x minus 1. So you should be able to factor that. Then we're going to set each factor equal to 0. So you get x is equal to negative 3 and x is equal to positive 1. Alright. So both of those are my vertical asymptotes. At those vertical lines, I will have a vertical asymptote. Okay? And that also tells me my domain. All real numbers except for x cannot be equal to negative 3 and positive 1. I just said or positive 1. And for my horizontal asymptote, we're going to look at the degrees of the function. This is degree 2. This is degree 1. Is bigger on bottom, so this is actually Bobo. Bigger on bottom, which means y is equal to 0. Now, I'm going to leave this one right here up to you, but it's the same idea as that one, and let's just go over 8, 9, 10, 11. Alright. So in this one, you really just have to look, alright? And you have to just make a decision. On this one, for example, you have a vertical asymptote at this line. How do I know that? Well, because this curve kind of gets really close in this one, but it doesn't go through that line, okay, that I just drew. Now, my vertical asymptote is probably right here, okay? Now, so my horizontal asymptote, just look at it. This is y is equal to 3, right? 1, 2, 3. Y is equal to 3 is this horizontal line. And my vertical asymptote would be x is equal to negative 2, alright? The other one that is a little bit weird is this one. Well, I have two that are weird, and I'll show you. Number 9, this one does not have a horizontal asymptote, right? It's slanted, right? There's actually a slanted asymptote, and if you see that, that means that my horizontal asymptotes, I don't have any, is none. Alright, my vertical asymptote, however, look at it. I get really, really close to that line. Okay, and that's okay if you do it wrong. If you draw a line in the wrong place and you go through the curve, well, that means you got to move it. So this is x is equal to -1. All right. Now let's take a look at this one. This tends to cause a little bit of confusion. Let's talk about the vertical asymptote. There's one here and one here. All right, so there's a vertical asymptote, so I have one at positive and -2. Now my horizontal asymptote, what really gets kids is the fact that I've told you all this time, you know, my horizontal asymptote, I cannot go through it, blah, 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 but it looks like this curve does go through it. Now, let's just worry about where that's at. That's y is equal to 0. And all I'm going to say to you about that is that essentially the horizontal asymptote, one way to look at the horizontal asymptote is not so much about where it can or cannot cross, but what the horizontal asymptote is that tells you the end behavior. As you go to negative infinity, this function, whatever this function is going to get closer and closer to 0. And as this function goes to positive infinity, it's going to get closer and closer to 0. So essentially for you, if you don't even want to think about that, all you have to know is this. Sometimes, especially in the middle, most of the time, but even sometimes through here, it can, on the horizontal asymptote, not the vertical, on the horizontal asymptote, it can cross that. But even if it does, it flattens out and it just follows that horizontal asymptote and it gets closer and closer to it. Okay? Well, if you have any more questions, let us know. Let's see if you can figure this one out. I'm just going to write the answer. I really haven't checked it. I hope it's right. And good luck out there.